Good morning, everybody, and welcome back to day 2 of the 21st Annual Leakage Conference. I have with me today Bob Taylor, who's CEO of Portsmouth Water, who's going to be chairing this morning's discussions. So I'd like to hand over to Bob now, who's just going to say a few words of welcome. So over to you, Bob.
Great, thank you, Judith, and good morning, everybody, from me, and welcome to this day 2 of the 21st Annual Leakage Conference. I'm sure as many of you are already aware, the reason why I'm sitting here today and why Pauline Walsh chaired yesterday and Peter Simpson will be chairing this afternoon is because we are the three co-sponsors of the Water UK public interest commitment around leakage. And I'm not going to repeat what Pauline said yesterday. She I think at the beginning of the conference in terms of explaining what that's all about, but there may be some newcomers today who haven't heard about that. So just briefly, what is the public interest commitment? Well, it's a commitment by the whole of the industry to meet the challenges posed by the need to reduce leakage. Specifically, it is to triple the rate of leakage reduction by 2030. And in terms of our priorities, in terms of doing that, well, what are we working on? Well, you'll have seen a great presentation yesterday, I'm sure, from Jeremy around the heat map, which is trying to identify pockets of advanced expertise and know-how and pockets of need equally as much around the industry, so that we can share and build on each other's knowledge and experience. We're building a route map to get us to where we want to go within the challenge, the basic challenge. We're working on, obviously, a centre of excellence, which is part of the innovation initiatives going on within the industry, which leakage is very much at the forefront of. And in simple terms, I think what we're trying to do to make all of these things happen and to achieve these ambitious targets is to bring collaboration within our industry. That's between water companies, that's with the supply chain, with regulators, collaboration in whichever way you look at it to a new level. And that is really starting to happen already through things like the innovation festivals that many companies have arranged. Of course, we're putting our first proposals together for the Ofwat Innovation Fund, and I'm sure you heard about that yesterday as well. So things are really starting to move. But I think in terms of yesterday, those of you that weren't around yesterday, I think having spoken to Pauline overnight, I think the sort of hot topics in yesterday's discussion were around the role of data and how much more data we are collecting nowadays within the, I suppose, the context of the smart revolution that's going on, and how we can manage and utilize that data as effectively as possible. And within that, of course, the changing role of leakage managers within the industry and how all of these kind of data management and smart stroke IT communication skills are increasingly important, and how the role is changing in that respect. There's obviously the evolution to smart networks. Leakage is the primary driver, I think, for that sort of revolution that's happening around the industry. But I think yesterday as well, there was very clear recognition of the importance of the job that we have to tackle here in the industry. Never has the profile of leakage been higher. Not just in the industry, but globally now, within the context of global warming and the need to conserve water and preserve water resources for future generations. So the stakes have never been higher. And I think people who work in the industry in all aspects, in the water companies, in the supply chains and so on, they really recognize that and are very passionate about succeeding in this area. So I think from what Pauline has said to me, that that passion certainly came out yesterday. And I was just thinking about this after speaking to Pauline, and here am I. I'm nearly 40 years in the industry. I started my journey in leakage in the in the early 1980s with the publication of Report 26 from WRC, and here I am again, still passionate about it in a somewhat different position than I was in those days. And there are a number of people in the audience today, Stuart Trove for one, who was around in those days, and we're still at it, still promoting leakage and trying to do it better and better and better, and understand it more and more. So I think that passion and that enthusiasm is reflected in everybody who works in this area. And it's a pleasure to work in this part of the world, business-wise as well, in the leakage area. So yeah, thanks very much to Judith and the conference organisers for letting us have this platform just to reiterate our ambitions as an industry in terms of the public interest commitment. It's really important to all of the CEOs in the industry. I sit on the board of Water UK. Along with most of the other CEOs, and this is a very key and important area. I also want to talk a little bit about the innovation and the initiatives around that in the Centre of Excellence. As I hinted on a moment ago, I really believe that leakage is in a very strong position, because if you look back over the last 30, 40 years, I can certainly look back to the early days of my career and see how much things have moved on. And there has been a continuous focus on innovation, particularly within the supply chain, to do things better. And of course, as leakage has reduced, the challenge has only increased. So we've had to get better and better. And because of the fact that we have been innovating, over that period continuously, I think we are in a stronger position than some other sectors to take advantage of the Ofwat Innovation Fund and to put projects forward that we can all learn from and that can really deliver that sort of quantum leap in performance, which is what I think we need to get to in order to achieve our tripling of the rate of leakage reduction. We've all got better at leakage reduction. In the last year, leakage in the industry reduced by about 7% overall, a startling performance in the last year of the last AMP. So, as things reduce, the challenge is getting tougher, and the need for the technology and the need for the innovation becomes even stronger. So I would just reiterate that message that if there's one thing we need to do much more of, it is the working together, it's the collaboration, it's the sharing, it's across the water companies, it's globally, it's across the supply chain. We just need to do much more of that, and use the things that are happening around innovation as a sort of a vehicle for that, and bring collaboration to a new level in this sector of the industry. So yesterday there were 179 people in the conference. So 172 one-to-one conversations, 99 meetings, 107 speed networking connections. So in addition to the presentations you'll see this morning and this afternoon, obviously there are many other ways that people can communicate and bring and make a start and develop on that collaborative journey that I've mentioned. So I really hope you enjoy this morning's presentations. I think we've got a series of 4 quickfire presentations followed by questions and answers. I do implore you to use the chat and start putting your challenges and your questions up there. Otherwise, people get bored of hearing my questions the whole time. So you guys out there know a lot more than me about this stuff. Please get the questions running, and that'll make it more interesting for all of us. So hope you're looking forward to this morning. I certainly am. Welcome. And let me hand back to Judith just for a couple of brief housekeeping points before we crack on.
Great. Thank you very much, Bob. Yes, so I'm just going to reiterate some things from yesterday, just to remind everybody, just in case. We have got some new people with us today. So Hop-in works best on Google Chrome or Firefox. So just if you have difficulties today, just make sure that you haven't inadvertently come in on another platform. They will work, but you'll lose some of the functionality. And one of the strengths of Hopin is that there is great functionality, particularly in terms of connecting with people. And the other thing is also make sure that you've not got anything else running in the background. So anything like Microsoft Teams or Google Meet, Skype or GoTo, switch those off, because they will be battling to have control of your camera and your microphone. And I find if I've got Outlook open, that really doesn't work, because it's buffering all the time to bring you messages. So turn all that off. If you're not really sure, just do a restart, and then that will make sure everything's cleared out. When you want to go into other areas and you want to network with people, particularly, you'll be asked to share and allow permissions for your camera and microphone. So you need to enable that when you're asked to. If you do have any wobbly moments during the day, maybe if your bandwidth goes a bit there, here and there, particularly when all the kids log in your neighborhood and do their classes on Zoom, you might just need to refresh your browser. And the other thing is just make sure that your volume is turned up and on. If you have any problems at all during the day, then do head off to sessions, which is over in the navigation on the left hand side. All the navigation is on the left, and go to the help desk, and Ben is there and he will be able to help you. Okay, and then just some other things in terms of just structuring your screen so that the presentations are as large as they can be. On the right hand side, you'll see at the top there's an arrow. Where this orange arrow is heading, there's a little arrow there, which means you can fold back the chat. Now, we really do want you to chat. We really want you to put your questions to our speakers, and also to connect with one another during the session too. But if you want it out of the way and have a slightly larger PowerPoint image, then fold that to one side. And the other thing that I also find helpful is if you go to the 3 dots up at the very top in your Google browser and head to setting, and then actually just go down and adjust your zoom, that can also make the slides larger, which can be really helpful. So that's all from me on the housekeeping side of things, and I hope to catch up with many of you during the day and enjoy the discussions. We've got some great presentations and the second part of our Operational Developments Forum, Technology Developments Forum this morning, and then we move on with Peter this afternoon, looking at Find and Fix, which is really a first for the conference. So I'm certainly looking forward to all of that. So thank you very much, Bob, for chairing this morning. I'll hand back to you and our first presentation.
Great, thank you very much, Judith. So as you've heard from Judith, this session this morning is a carryover from yesterday's session, covering the broad area of operational and technology development. So that's a big chunk of what we do in this area in the industry. So we've got quite a wide spread of papers. I'm sure you've seen them all in the program there. But firstly, it gives me great pleasure as the CEO of Portsmouth Water to introduce these next 2 speakers who are going to be talking about the challenges of locating leaks on plastic pipes. Our network in Portsmouth Water is about 50% plastic, which is surprising, as it only seems like yesterday when we started putting it in. But anyway, that just shows how old I am and how long I've been around in the industry. So yeah, I'd like to introduce Alex Barter, who is a director of Barter for Things, which is a relatively, I say not brand new, but a few years old startup business focusing on Internet of Things technology, amongst other things. And also Jamie Jones, who is our Leakage and Smart Networks Manager at Portsmouth Water, and dealing with all things smart and leakage and innovation related. So great to see both Alex and Jamie on the platform this morning, and they're going to talk about some work that we've been doing in Portsmouth using IoT technology and pressure data to try to improve the way we locate leaks on plastic pipes. So Jamie, Alex, over to you.
Well, thanks, Bob. I'm still waiting for Alex to arrive on the screen. So Alex, are you there? And Right.
Hello, Bob and Jamie. We're just trying to find Alex, and we'll bring him to you as soon as we possibly can.
Okay, that's all right. Well, as always, I've got a backup, and so I can start talking while we are waiting for Alex, and I will share my screen instead. So here we are. Bob, can you see my screen? Good, excellent. Thank you, Bob. Thank you. So, okay, and while we wait for Alex to come in, I thought I would start by introducing myself. I'm Jamie Jones. I'm the, as Bob said, the Leakage and Smart Networks Manager at Ports of Water, and I will be joined by Alex Barter, who is the Managing Director of B4T. Over the past few years, Alex and I have been collaboratively developing an IoT pressure sensor that has lowered the cost of pressure logging. This logging is primarily developed to fulfill the regulatory need to have a pressure sensor at the average and critical point in each of our DMAs. But with budgets are very tight and plenty of DMAs with no signal, these low-cost IoT pressure sensors became the most cost-effective solution for dealing with this issue. This project was very successful and got us thinking about how we could utilize these sensors for more, and in particular for leakage detection. The result of this was a practical IoT, and it's what this presentation is about. And the result is really an alternative way of finding leaks on plastic pipes that will reduce the runtime of a leak from about a week on average for us at the moment down to a day. So at Ports of Water, as Bob has just said, we've always had a very strong mains renewal program and taking it very seriously, historically renewing around 1% of our pipes a year. This has meant that we're actually up to a position now when we have, as Bob said, 50% of our network plastic. Now, I need to tell the Leakage Conference that finding leaks on plastic pipes is very difficult. And these traditional techniques have normally been very costly or have returned a large number of false positives. At the moment, Ports of Water conduct a large number of step tests on the network in these areas of plastic pipes, and as well as being costly, these can lead to customer interruptions and flow reversals and an uncalm network, and so it's not the most ideal solution. I therefore set Alex and his team the challenge of using the IoT loggers to come up with a solution that returned better results for us and were more cost effective. So yesterday I spoke with Robin Bell at Informatics about the benefits of calm networks and an automated network model. In Jez, his presentation, he talked about the Palm model, and the digital twin is a key objective is to take the calming of the network to prevent that. That's the P in the Palm, prevent leaks occurring, while also providing the secondary benefits of the awareness and location. Practical IoT flips this round. The aims here is to find leak quickly, so to lower our awareness or A in the Palm, especially on plastic pipes, and also help with the location of those leaks on the plastic side. So it's about the A and the L in Jez's Palm model. So practical IoT and digital twin for us are combined with the fixed noise logging of metal pipes that we've also done over the last few years, provide the kind of free solutions for us that are going to help us reduce our leakage over the future. So why is it important that we have new detection methods and new awareness methods of leak detection at Ports of Water? Well, people have come to me recently and said, you've done great reduction over AMP6, why don't you just carry on doing more of the same? But the fact is that we actually threw the kitchen sink at leakage over the past few years, and this reduction therefore came at a considerable cost, and this cost is very unsustainable in the long term. Well, yes, we have managed to get our leakage down, but in recent times it has now flatlined at this lower level, and has been the same really since the start of April 2019, as we've had to scale back on the amount of money that we have spent on it. But of course, to achieve our 50% leakage reduction target by 2050, we actually need to reduce leakage much further. There is no kitchen sink that can be thrown at this time. And really, there is no magic money tree available. Unsustainable costs will lead to unsustainable results. And either that means either spending too much in this area and underspending on other areas, or not achieving our goals. We therefore have to be smarter in order to progress. And at this point, I will pass over to Alex, who is far smarter than me, and go into the details of what IoT really means. So,
yeah.
I'm going to stop sharing and let you share now this time.
Great. Thanks, Jamie. I don't know if I'm smarter than you, because clearly I couldn't use the the Hopin app particularly well, but here we are. Okay, so you might be forgiven for thinking this is sort of like a strange game of Guess Who. They've got glasses and facial hair and so forth. Right, I'm going to pick up from where we were. So, bada bing. Hopefully we've got some slides, yeah? Okay. So, Jamie, can you see the slides okay?
Yes, they're just loading now, Alex.
Brilliant, okay. Well, it's clear what keeps Jamie awake at night, and I think probably BT's bandwidth to the office is keeping me awake at night. Anyway, so Jamie's set out a challenge. So challenge accepted. So when we got a challenge, we think about the solution. I was revert back to my my triangle of truth. How can we solve things better, cheaper, quicker, so on and so forth. So we've got some critical success factors in and around working in plastic to certain levels, making sure that we're timely in what we do. But also back to the no magic money tree, we've got to be thinking about the pound in our pocket. Now, the headline of the presentation is around IoT data, and it is IoT data that I major in, that I can comment more about. But on top of the IoT data, which has to be good, it has to be the right ingredient. We tried different methods of cooking this data in order to hit these critical success factors. So I am sure that Tom over at Royal Haskoning and Stuart over at SME will wax lyrical about AquaSuite and about the SME product. So just to put in the picture of our approaches. So one way of cooking data is to use a machine learning platform with a hydraulic weighting in. A second method was to use people and expertise with some automated hydraulic analysis. And then the third way was homegrown from B4T, who know zero about hydraulics. So we just went with pure machine learning. Now we can sort of typecast where these different data solutions would sit in terms of their quickness, goodness, and cheapness, as it were. The reality is these things are a lot closer than you think, in good ways. So back to the point that I think I probably major on. So you have to have a decent ingredient. You have to have good data. So we've deployed extensively with Portsmouth over the last 3 years IoT sensors using the 0G stack from Sigfox. So this represents like a new sort of boundary in how we collect data. It's ultra lightweight. It's low cost to implement. And what I thought I'd do with this presentation, I'm going to come back to it in a bit, is to kind of talk a bit about IoT in terms of that that real how you implement it, because it's, you know, it's much discussed, but I'd venture little understood. Anyway, so going back to this particular project, so we've got 10 of these IoT sensors in and around a DMA in Portsmouth. We simulated bursts by, you know, performing flushes and so forth, and the results were consistent. So I've got a map here with the AquaSuite software, and the two yellow stars are where we've got the nearest pressure points. Up to the top right, we have the machine learning platform that we built in B4T. What we've done there is we identify periods of significant change in flow, and at the same time we're performing machine learning every 15 minutes on all of the pressure devices, and we look for the you know, the most significant drops in pressure.
Alex, can I just stop you there, because I think the slide you're trying to show is, oh, it's taking a time. I think it's just loading up now. Yeah, I think we got it now.
Oh, sorry. Okay. Sorry, Bob. Okay, so the slide I'm on now, which says "and verifying manually," this is the analysis from our friends over at SME, so Stuart and Rashid, and same thing. They nailed it as well. So we've got the same results. So 3 different approaches, all in their own way, all achieve the same results. So, you know, IoT data got to be good, and then, you know, we have we have our scope to deploy. Now, we've made a good start. So where do we go next? How do we take this to scale up? So there's 2 parts. One part is better mathematics. What can we do with the approach we have to optimize the data? So for instance, there's an approach to encode the hydraulic model. That's what we call a directed graph. There's a second approach to improve our machine learning modeling by using tensors or artificial neural networks. And then there's a third approach, which is to look at feature extraction by converting time-based events into frequency-based events to extract salient features. So that's in the maths. Now, you know, open hand I shall play here. My maths at A level wasn't massively successful. So I look at more at cost benefit. So my job is to now drive down the cost of the data point so we can start to scale this up, you know, to achieve full rollout across entire water company operations. So I'm going to take a little bit of a sideways jump and, let's say, talk about the implementation of IoT in that sort of detail. Like I say, much discussed, but little understood. So what I want to do is I take the concept of IoT, what is it that challenges us, and how is it that we crack those challenges? So what I've thought about is something that we're all used to. So noise, you know, maybe a little less these days as you know, as things are in lockdown, but noise. We're going to use this as an analog to understand the challenges around IoT. Leaves, dogs, and Motorhead. Okay, so on this slide here, hopefully this is loaded up, I've got 2 bars to the left, and I've got a photograph of something that looks like a pipe that would you know, come down from the toilet. That's a boundary box. So let's explain what it is that we're looking at and what analog we're using. So we want to understand, what is it about IoT that is special that makes it applicable for water applications? So let's think about sound, something that we understand. Now, to the left, I have a range of things that go from very loud at the top to very quiet at the bottom. and you'll see a little symbol, dB, that's decibel. So sounds are described by decibels. The next box along is radio waves. And again, slightly different, but still it's described in decibels. So let's think about sound. So the human ear can detect between around about 20 decibels up to 120 decibels. Okay, that's a dynamic range. So we can hear things very quietly at 20 dB as a whisper, and then up towards 100 dB is a loud rock concert. Then up to 120 dB is where you sustain damage from standing next to a jet engine. And then right at the very top, the loudest thing ever recorded was Mount Krakatoa exploding in the late 1800s, which was 180 dBm. So we've got sound. Sound has got a dynamic range. Now into radio, and this is where IoT lives. This is the challenges that we have to overcome in IoT. Your DAB radio will operate round about minus 70 dB. That's tiny. So your radio will pick up tiny, tiny amounts of power in order to deliver your Six Music or Planet Rock or whatever. IoT exists much lower down. So IoT is in this dynamic range, round about minus 90 to minus 150 dBm. Tiny, tiny, tiny. So even though we're working in a small dynamic range, let's have a think about our physical challenge. Now, if you look to the photograph on the right, this is a boundary box. So this is what houses smart meters, also pressure devices and water quality sensors all over your estates. So there are things that suppress our dynamic range. So one thing is having a lid with metal in it. That normally gives us somewhere between 10 and 15 dBm of loss. And then as we go down, 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 we can lose anything up to 20, if not more, dB. And when you compound that, I hope you're all still following, we're down, right down to the equivalent of hearing a leaf fall or something that only a dog can hear. So IoT is in these extremely challenging radio environments.
I'm going to have to move you along a bit, Alex, because you're running out of time. So,
fine. Last slide, Bob. Last slide. Scout's honour. Okay, so in order to meet these challenges, there's a couple of things we do. On the left, we're building smarter, much more highly acute listening equipment in the IoT realm. So the radio's listening better. And on the right, we're bringing in new devices that transmit with much more pinpoint accuracy and better power transmission ratio. So here we go, right at the end. What are we going to do? You'll hear more about jellyfish and smart metering very, very soon. And my job is then to bring that into the world of pressure, so we can then, roll this out and meet these pressure demands. And that's it. Finished.
Well, that's a really good speed up, Alex. Thanks for that. Anything more from you, Jamie, or shall we move on to questions and answers?
So obviously, Alex, you there's a slide in the middle there that kind of got frozen. So I just want to kind of emphasise on that point. So it is very similar, as you say, to presentations that were given yesterday, in that the idea here is the pressure sensors are localising down into an area. So it's where these leaks are, and so it's using the pressure, and it's using the differentials in pressure between the different sensors that are out there. And the difference that we have compared to what was said yesterday is purely a different sensor logger, and Alex is using a different technique in order to get there. But it's the same principle as what was done yesterday, explained yesterday by both Daniel and also by Stuart. So yes, it does look like we're all on the same page, and it very much is that we're all looking the same way. And I think the key thing that Alex pointed out is that all these different solutions, they all have their benefits, and they could all work in different ways in different areas. And I'll stop there.
Okay, that's really great presentation from you both, in spite of the technical challenges at the beginning. A great recovery there. Thank you. Well done, Alex. So there's a few questions there on the chat, which maybe we can kick off with. So Adam Smith is talking about, maybe for you, Jamie, how what leakage runtime that we're talking about here. How do we know what the runtime is before we have realized there's a leak there? I suppose that's the crux of the question. So you talked about a week. What is that week that you're talking about?
So we're quite fortunate at Portsmouth to be quite a small area. And so what that means is we can look at the night lines of every single DMA that we have in great detail. And so in calculating the average runtime of a week, this has been done by a mixture of myself and consultants as well, in looking at the changes in nightline from a minimum level as they increase. And then taking in all the data and all the information that we have around how long it's taken our guys to go out there and find these leaks. And a lot of this work was done back in 2015 and 2016 in preparation for the fixed noise logging and work that made a big difference in 2018. You saw on my graph with that big reduction in leakage. But it's the same principle for the plastic side. The guys beforehand were going in and looking for leaks, and it was taking an average of a week in order to find each leak. And what's probably worth putting in the contents is that for us, our DMAs are much larger than most other water companies. They're averaging somewhere around about 10,000 properties. And so when I do give an area to a leakage tech, and there's certain areas in rules that are very large, I can see that them just looking at me with deathly stares and daggers as I've given them this huge area to look for leaks. And as we reduce leakage down, and as again, as I spoke yesterday, we start going into these areas much earlier and before they've risen too much. They are looking for small amounts of leaks in much larger areas, and they need all the help they can get.
So what you're saying is that potentially, we had a revolution a few years ago with noise loggers, which are now being deployed in large numbers and are very helpful in general for iron or metallic networks. This could be the next best thing on plastic networks, the mass deployment of pressure rather than noise, yeah?
Yes, very much so, yes.
So kind of combination of questions here. Ben has mentioned, what do we need to do to accelerate the development of the sensors? I mean, and I'd like to add to that, Alex, what are we talking about in terms of cost differential, ballpark? What is between...
I think I did cheekily reply to Ben. There is cost to design, for manufacture and all this sort of stuff for sensors. So historically, for us, bringing an IoT device to life, capital spend is around about 35 grand. So that's in designs, certification, testing, so on and so forth. Sorry, that's a pretty straight answer. That's what it is.
Yeah, but in terms of my question, what I was getting at, Alex, was can you give us an idea of, what is the difference in cost, broad ballpark, between the low-cost pressure sensors, the low-cost equipment that you've been deploying here, and what it would have been previously, for example?
Yes, absolutely. So we understand that the market rate for GSM loggers is around 300 quid, maybe 400 quid. And in the IoT domain, where we are looking at single purpose sensors, we're down at around about £170 today. But like I say, my mission is to get that below £100.
Right. And another question there from Stuart. How is this different from NB-IoT, which is kind of used elsewhere?
Yeah, sure. So I'm personally up for using NB-IoT when conditions are correct. So there are two things that we need to get over the line with NB-IoT. Primarily, it's the supply chain of the radio modules. So other flavors of IoT like Sigfox or LoRaWAN, we understand the power consumption well, and in NB-IoT at the moment it's significantly more. So we're waiting for that to come down. And secondly, on the network, I think Paul asked a question earlier about, sort of putting new infrastructure out. Always, you'll need to put new infrastructure out. Doesn't matter whether it's NB-IoT, Sigfox, or whether it's the GSM network. It doesn't matter. There's always a need for more infrastructure. With the likes of Sigfox and I guess LoRaWAN, we control that infrastructure. Less so with NB-IoT today. Whether that will change or not, who knows? But certainly, the second part of my answer to Stuart is control over the network infrastructure as well.
So, Bob, I've got an additional point on that. So I have spoken with NB-IoT and the people who supply that, and the issues are very much in the rural locations. It's a cost benefit of deployment. It's much easier to deploy where there's lots of people. But unfortunately for water companies, there's a lot of our assets are in very rural locations, and this means that there's very much a gap in the market at the moment, or a gap in the market. Semantics would use an issue that we need to solve in the water company in these areas, and Sigfox came out easily as the kind of best solution in these very, very, very poor signal areas. It's also worth noting on the battery life, that is a huge part of the cost benefit for us. That was around the pressure sensing. The batteries are far cheaper and don't need to be replaced, or if they do, and they are very, very much cheaper than the ones already out there at the moment and needed for the other types of loggers. And so in doing a cost benefit, it's all about the whole life costs of loggers is where, and this even stands out even more as the kind of right solution for us anyway, with our challenges.
Yeah, I mean, I think just picking up on Paul's question there, did we install any additional infrastructure for the Sigfox? The answer is yes. We created a network, I think, isn't it, in simple terms, using our existing sites to facilitate those installations. Sorry, I'm just going to move on because there's a whole load of questions here. Really cracking question here from Glenn. How is the IoT kind of development changing the economics of managing leakage compared to standard approaches? This is down to the the fact that we're spending less time finding the leak predominantly, I think, isn't it, Jamie?
Yes, yeah, very much. So because the sensors are cheaper, it means that we can deploy more on the network, and therefore you're looking at finding leaks in a much smaller area. These pressure sensors can also then be used for a range of other applications, including the digital twin that I mentioned yesterday. And so what it's doing is it's really making things like digital twin and step testing not needed. So making digital twin far more cost effective and step testing not needed. And step testing is a very expensive way of doing leakage detection. It only just works out cheaper than just going out and looking for leaks. By the time you take in overtime and the chance that the leaks could be spread out a bit and things like that. So, and all the planning involved. So very quickly, step testing adds a lot of extra burden. And by doing this, you're very much changing to having this data coming in every 15 minutes, leaks coming through every day. And so therefore, you're also dramatically reducing that run time. And so therefore, it's a case of finding leaks much quicker. And so you're just doing a lot more of what you're doing, but a lot quicker. And that's where the economics start to really change. It becomes cost effective to do this.
And is it too early to go into Louis' question there? Is it too early to see impact on DI at the moment, or is it because it's still relatively in its infancy, isn't it, in terms of deployment?
Yes and no. I would say, and DI from a smart metering side, there's certainly stuff there and it can be done, but it is quite early in that smart metering world. But obviously, other companies have done a lot of work in smart metering. From leakage point of view, this summer there was, unprecedented demand on the network, and if we had had leakage up at the higher levels that we had back in 2017-18, we would have been really struggling for water in certain parts of our patch. But because leakage was lower, that gave us the additional headroom. So DI includes leakage. And if we can reduce leakage as we have by 10 megalitres a day, and we're going to reduce it further over the next period, then that does obviously reduce a DI and gives us that additional headroom needed for these peak demand periods.
I think we're going to have to draw the session to a close there, guys. So, I think you can tell how interesting the session has been to everyone by the questions there, many of which we haven't had time to answer. But I think there are other ways that people can pose their questions through the various networking mechanisms available. So thanks to everybody for all of those questions. Really interesting stuff and a great start to this morning's session. And it remains for me to thank Alex and Jamie. Alex, for a quick recovery there after a bit of a technical glitch. So well done for that. And virtual round of applause from everybody. Thank you.
Cool, thank you.
Thanks very much. All the best, guys. Have a great one.
So I think now we're going to set up for the next part of the next session in the morning, and that's a paper from Chris Rees, who is the Leakage Strategy Manager from Welsh Water, Dŵr Cymru, God's own country, I would say, as a proud Welshman, and Steve Toombs, who's the Executive Director of Invenio. And you can see them already on the screen there. So hopefully we're all connected up. And we'll crack on. Over to you, gents.
Thanks very much, Bob. Just do a quick sound check. Everybody, can you hear me okay?
Yep. Loud and clear.
Great. Good stuff. Good pronunciation of Dŵr there as well, Bob. So good morning. So Chris Rees, Leakage Strategy Manager at Welsh Water. So I'm delighted to be able to speak again today on day 2 of what has been an excellent conference so far. Today I'm going to give a brief introduction to Project Cartref, our customer-side leakage and water efficiency program from 7, before handing over to Steve from Invenio to kind of delve into the technology deployed and some of the findings. Next slide there, please, Steve. I feel like Chris Whitty. So firstly, I just wanted to touch upon our unique not-for-profit, not-for-shareholder profit business ownership model, which I believe is a key facilitator in the success of this project. It really does allow us to put our customers at the very heart of our vision, and that vision is to earn the trust of the customers every day. The trust developed with our customers has allowed us to develop our ambitious customer-side leakage and water efficiency program, Project Cartref. Cartref meaning home in the Welsh language. So next slide there, please, Steve. So we split our approach, proactive approach to leakage detection between customer side losses and distribution leakage. So this is owing to the very different skill sets and technologies required in order to tackle these problems and to also ensure we get the right level of focus on these issues. So we had some very much frontier projects, I guess, yesterday afternoon in located distribution leakage. And I look forward to following up on some of them, actually. So, but today we will focus on the customer side losses. So I think that fits quite nicely. So next slide there, please, Steve. So where's the leakage? So this slide shows our current estimate of distribution and customer side leakage. And as technology and meter penetration develops, so does our understanding of where the leakage is. So over the last few years, we've undertook extensive studies with our partner Invenio, which really have redefined their understanding of customer side losses and increased their estimates to almost 25% of total losses. I think that really emphasises the importance of having this dedicated programme. It's reduced the quantity of water that we estimate as background losses, and I'm sure as technology and smart metering and as such develops further, and you know, some of the frontier work that Alex and Jamie just showed there advances, we can really redefine what background losses actually are, and I'm sure this is going to be the subject of much research over the coming years. So we can move on to the next slide there, please, Steve. Project Cardiff, it's a proactive program targeting problematic DMAs with high ILI. They are primarily largely densely populated and usually made up of at-risk leakage property types based upon the age and supply pipe material. So we've committed to survey over 200,000 homes over the next 5 years and undertake tens of thousands of home visits off the back of them. And it's at the home visit where we can repair the leaks, whilst also undertaking the opportunity to install a wide selection of water efficiency devices. And in addition to that, it's a fantastic opportunity really to have a conversation with the customer regarding their water use. We can provide information on other business initiatives as well, such as our meter options, and linking into sort of retail and waste strategies to help promote affordability tariffs, priority services, and Stop the Block campaign. Next slide, please, Steve. So, animations and slides.
The slides don't appear to be updating at the moment, just to let you know. I've still got the where's the leakage slide up on my screen.
Okay, I can see a Project Cardiff slide with the 5 steps.
It's probably a problem with me then. Yeah, it's okay.
Is that what you can see as well, Steve?
I can see the same as you, but the 5 steps, Project Cardiff.
Okay.
Okay. Oh, Jamie's on the Cardiff slide too. Excellent. Thank you, Jamie. This is interaction as we need it. Oh, Joe Parker as well. So I'm actually going to hand over to this point because the going's getting tough. So yeah, Steve's going to speak about step 2 and step 3 in a little bit more detail. Over to you, Steve.
Thanks, Chris. Okay, next slide. Can you put the next slide on, please? Okay, so I am going to cover the that's sort of step 2 and step 3 of that 5-step process, and really concentrating on our use of stopwatch surveys as part of Cardiff. Next slide. Next slide. Right. So in Invenio Systems, it's been, well, we've been established for 6 years now, nearly 6 years, and we've really, the basis of the business has been pioneering the use of temperature measurements in the distribution system, and both on customer supplies, which is what I'm going to be talking about, but also further up in the distribution and trunk main systems as well. Next slide. So, so we've been involved with Welsh Water while they and us have been developing the Cardiff concept almost since the beginning of Invenio Systems, and we've got to the point now of when we're working with Welsh Water on Cardiff over the whole of the next AMP7 or the current AMP7 business plan period. Next slide. And this is a sort of summary of the Cardiff, or our bit of the Cardiff process. So there's the area selection, an acoustic logging and leak detection stage in the distribution system, and then moving on to doing a stopwatch survey, which is a survey to find customer side losses, which is both plumbing losses and customer side leaks, underground supply pipe leaks, as well as identifying night use. So there's a whole set of benefits that come out of doing that stopwatch survey, which then inform further decisions and also identify real leaks that the Welsh Water can then repair. Next slide. So I just wanted to describe quickly what stopwatch does. It's a high precision temperature measurements on external stop taps, and we use the data that we get from that temperature measurement to identify customer use and to identify and quantify leaks. So the logger, which is a picture on the right hand side there, goes on the stop tap, which goes where at the junction between the communication pipe and the underground supply pipe, mainly on domestic properties. Next slide. So this is a representation of how of what we do and how the temperature, how we use the temperature measurements. So this is a representation of a boundary box with a communication pipe coming in on one side, underground supply pipe going up off on the other side to the house. So the little picture on the right hand side indicates the pattern of water use by the customer, and the picture on the left hand side indicates the little graph on the left hand side indicates the pattern of temperature in the water main. So you get this characteristic diurnal pattern of temperature that varies, and that graph is shows it over 2 days. So when water's used by the customer, or water's drawn through the communication pipe, and that as that water travels along the communication pipe, there's a transfer of heat between the pipe and the surroundings to the pipe and the water, and that produces a temperature change which you can measure in the stop tap. So so we can interpret the temperature that you see in that middle graph and to work out what the customer demand is using effectively a hydraulic and thermal and hydraulic model of that set of pipes. Next slide. So so if you had a short intermittent flow, so someone running water for maybe 30 seconds at 6 litres a minute, so maybe washing their hands, you get the green line indicates that flow, which is you can see on the right hand side of the graph, and the black line shows the temperature response that you get at the stop tap. So this is a modelled result. So you can use that temperature to identify that use event has happened, and also to quantify it. Next slide. But when you get a leak that's a continuous flow past that point, which might be due to a leaking toilet or a dripping tap or an underground supply pipe leak, you get a very distinctive change in that temperature profile, which is quite easy to identify. And so we can use that to identify that the leak's going on, and that change in the profile is also dependent on the flow rate of that leak as well. So we can identify to some extent what the flow rate of the leak is as well. Next slide. So we've done a lot of verification of our results against metering. This is just one example of where you can see that the black dots are average daily consumption for individual properties, and it's comparing the metered average daily flow to our calculated average daily flow. And you can see you get a really good correlation between those two. Next slide. Okay, so this is one example of the temperature data that we get. This is data over 7 days for an individual external boundary box. So this is an unmeasured customer supply, and you can see that you get a set of peaks and troughs corresponding to customer use, and then during the night when there's not much use going on, in this particular case, you get a very flat profile of temperature. So we can interpret that data to calculate how much water that customer is using. Next slide, please. Okay, so this is another odd example. Between 2 and 3% of the customers that we survey, we get this kind of result from. So, and you can see that every 10 minutes or so, for the whole of this log, or for most of this logging period, you get regular peaks in temperature, and this corresponds to a toilet where there's a leak out of the bottom of the toilet system, which is being fed periodically by the opening and closing of the inlet valve to the toilet system. So a reasonably common cause of leaks, and we see this quite a lot. Next slide, please. And then this is the kind of temperature profile we get when there's a significant leak. I think this one is something around 200 litres an hour. So we can identify that as being very different, and we can highlight those as being leaks that need to be followed up to resolve them. Next slide, please. So in the Cartref process, we survey whole DMAs. So we put a stopwatch logger on each stop tap in the DMA, and we end up with hundreds or maybe thousands of individual temperature profiles. So I've got 2 examples on the left-hand side. We process those to calculate the flow rates that going past each stop tap, and then we can use that to identify individual leaks which need resolving, but we can also add all that data up to get a diurnal profile for all the properties in that DMA, so which is indicated in one example on the right hand side. So we may end up with, I don't know, 1,000, 1,500 individual surveys that go into this profile. Next slide, please. So this is one example of the results we got. So the orange line here is the DMA meter flow, and the blue line is the sum of all the stopwatch survey results. The picture on the left shows that each green dot is each property in that DMA that has been surveyed. This is a DMA in Newport, and we identified a set of leaks, and we've also identified a set of individual properties from the stopwatch data which are high users, which can then be used as part of the focus for water efficiency program. But you can see that those blue and red lines, although they match up each other pretty well, they are the orange line is moved up, and that's because there is leakage in that DMA which is not going through the stop taps. So in this case, we've got some distribution leakage as well as getting leakage in the as well as having customer side leakage.
If we hurry you up a bit, Steve, because there's a lot of questions out there waiting for you.
Okay, right. Next slide. Next slide, please. Okay, so this is a sort of typical result we get, and I just wanted to highlight that that in the sort of traditional approach to this, you would identify this diurnal pattern that you get on the left. So this is a typical day out of that 14-day period. That typical pattern, you'd interpret it as 2.3 litres an hour of night use, about 1 litre an hour of customer side losses, and then the rest of it would be distribution system losses, which you would then go and look for. The stopwatch results shows that actually there's a lot more night use in this particular DMA. There's quite a lot of customer side losses, and so the distribution system losses are actually less significant. You can also see that we get a really good match between the average daily DMA flow and the sum of the stopwatch data. Next slide, please. This is another example. So it's a DMA. It's actually on the banks of the Severn estuary. In this case, we've identified that actually there's very, very little distribution losses in the system, in spite of the relatively high minimum night flow. And there's actually a lot of customer side losses and quite significant night use as well, which is so that would drive you to do something completely different with this DMA compared to what you would do if you thought it was all distribution system losses just from the DMA data. Next slide, please. So if we take all the distribution system, all of those stopwatch surveys, we can use it to look at the distribution of unmeasured household consumption, and also in this case unmeasured household or all household night use. I just wanted to illustrate that there's an incredibly long tail of night use, and that very long tail of night use, where you've got quite rare but really important but really significant customer night users, produces a very big variation in night use actual night use between DMAs. Next slide, please.
Should we pick up on some of the questions, Steve? Just mindful of time.
Okay. So just wanted to say that produces a very wide distribution of losses. So yes, okay, let's pick some questions up.
Okay, so the first one here is from Louis, who said, can you use so brief answers, please, because there's a lot of questions.
Okay. Okay.
You need to be quick fire on this. So can you use these temperature loggers to predict burst outbreaks in the water company network?
Yes.
Yeah, not that brief.
Yes. So I think there's two things we can do. One of them is to measure the temperature of the water in the distribution system and use that to predict where leaks are likely to happen. The other one is that we can use temperature measurements in the distribution system to identify in which areas of a DMA that a leak has occurred, in a very similar way to that you can do with pressure.
I think that's picked up with the street level sensing project, which is ongoing with probably 9 or 10 water companies at the moment.
Okay, so what is this impacting? Paul's question here, Paul Parr. How is this impacting the sort of people that we're using now to follow up on this data? Are we? I think he's effectively saying, are we using leakage technicians, or are they more like plumbers, or something in the middle, perhaps?
Yeah.
I think, Chris, that's for you.
Yeah, morning, Paul. About that. In short, we've kind of recruited from our leakage detection resource because what we found was we had some skilled plumbers in there. So I guess it's very much linked the two sorts of industries over the years. So we found that we had some already qualified plumbers within our teams. So we've kind of gone through a process of upskilling those, putting them through WaterSafe accreditation, so they are multi-skilled, and we kind of equip them with lots of different equipment at the moment. And we can't hide away from the fact that the lockdown restrictions have prevented us from entering homes. But we're hopeful once things open back up, then we can continue with the internal home visits and the installation of water efficient equipment and undertaking the internal repairs also.
Okay, there's a question from Joe here to you, Steve. How does the condition of the pipe affect thermal transfer in terms of, old rotten galvanized iron pipes compared to newer pipes, even plastics?
Okay, you definitely get the clearest results on thin-walled metal pipes. But we can get results on all the materials that we've come across. There are differences, but we can use the temperature data to understand what the effect of those differences is. So yes, the outside temperature does affect it, but we correct for that. We take account of that.
Okay. And another question
really interesting
on the customer impact for you, perhaps, Chris. Did you get any hostility or any plans or any difficulty with customers, or did you get full cooperation?
I think it comes back to that trust piece at the start that I mentioned. We are a very well trusted business within Wales, and we've got a good relationship with the customers. We've actively promoted our not for shareholder profit status, and it's all kind of led to that trust. So what we're seeing is far higher appointment rates than what the similar kind of offerings with utilities would have. So we are managing to get through the door. There is some hostility with some customers, and you kind of get those non-engagers as well. And Steve's slides highlighted that distribution of customer use, and you see a very long tail on that, and they tend to be the non-engagers as well. So they are a challenge. We don't have a compulsory metering policy at the moment, so those customers do pose us with a challenge. But we've got a very strong comms team to sort of follow it up, and it kind of links into Michael's question there as well. Michael Wilmot just asking about the impact on the PCC ODI, and a large part of the Cartridge program is part of our water efficiency program to target those high users and have almost street level comms campaigns and product offerings. So yeah, one of the big outputs of Project Cartridge is our water efficiency campaign also.
Okay, I think we've answered one way or another most of those questions. Perhaps just one from my perspective. I mean, what is all of this doing to our understanding of background leakage and the assumptions that we've been making?
Okay, shall I answer that one? I think the more work we do, the more we realise that the outliers, the unusual customers have a really big effect on the overall assessment of consumption, but they tend to have been rejected or ignored rejected as outliers, as unlikely to be true.
Yeah.
Once you start including those, I think it explains a lot of what background leakage actually is. I think a lot of background leakage is actually consumption. It's really difficult to find it and detect it.
Yeah. And this is probably an area we need to to do more research in, would you
Yes.
say, Steve and Chris? Yeah.
Oh, definitely. It's because I mean, if you start thinking that background leakage might actually be consumption, then it starts to explain a lot of the things, like the fact that in spite of the effort that was put in the UK on leakage management, we don't seem to be at the forefront when you measure actual leakage levels.
I think thinking about Jeremy's heat map from yesterday as well, I think we probably need to have something specific on background losses and do a bit of an in-depth study as an industry into that and try and get a better understanding, because our leakage ambitions to 2050 mean we need to be below our background loss estimates. So clearly we need to have a better understanding of them.
Yeah, I would certainly agree with that. And I think over the years we've been through all of these various assumptions that we made all those years ago in the BABE software and so on. We've been collecting more data and verifying reservoir losses, trunk main losses, all those good things. Still need more, mind you, but it's improved certainly. But background losses is something probably we haven't done as much on as in other areas. So I would certainly support that view.
Yes.
I think we're time's up. Unfortunately, we could carry on this discussion for some time, I'm sure. So it remains for me to thank Steve and Chris for another really great and stimulating presentation, and thanks to everybody on the floor for their questions as well. Maybe Chris and Steve, there are some questions there that we may not have got round to, but I'm sure you can follow those up on the chat separately.
Absolutely, yeah. Thanks very much.
Great, thank you. A round of applause, virtual round of applause again. So well done to you both, thank you. So moving on then to the next presentation, we've got Dean Marshall-Say, who's a director of Artesia, and Eldos Then, who is an asset manager at Affinity. And they're going to be talking about, I think, a challenge that is very common to the industry, which is around the changes in demand as a result of COVID-19. It certainly had a big impact in my company, and I know there are many others in that situation as well. So over to you, gentlemen.
Okay, thanks very much, Bob. Good morning, everyone. I'm Dean Marshall-Say from Artesia, and in a short while I'll hand over to Eldos. So today we're going to talk about some of the insights that we've got from doing some work with it's a collaborative project with about 15 other companies and the Environment Agency, who have all shared lots of data to try and really understand what's been going on during this period since we went into lockdown in March 2020. Look at the impact that's had on how we use water in the network, and picking up on some of the things that we've been hearing this morning about customer use at night and how much of that is actually demand rather than leakage. So to kick us off, I'm going to hand over to Eldos, who's going to give us a bit of a background.
Hello, my name is Eldos, and asset manager in the network analytics from Affinity Water. I've been in the water industry for 4 years with previous background in retail analytics. Just a little bit on Affinity Water. We are a water-only company with our commitment to deliver high-quality water service to our customers. So we provide about 900 million litres of water every day to a population of 3.6 million people. We cover parts of Bedfordshire, Berkshire, Buckinghamshire, Essex, Hertfordshire, Surrey, and some borough in London. We also supply water to the Tendring Peninsula in Essex and Folkestone and Dover areas in Kent. So I do not think anyone is expecting a pandemic of this scale in the beginning of 2020, as my CEO has put it, once in a 100-year global pandemic. Nothing has prepared us for lockdown and prolonged working from home or homeschooling. And nothing has prepared us for the increase of consumption due to the heightened regime of hygiene. But one area that gave Affinity Water a big surprise is the apparent leakage of approximately 20 megalitre, as you can see from the slide, through the summer of 2020. Over M6, Affinity Water had worked hard to reduce leakage to meet our M6 target. So we're not going to let this momentum slip at the start of M7, but come this 20 megaliter increase over the summer. Like all other companies, we scour and analyze the data to try to understand this increase. Hence, this presentation to share our findings on night use during COVID in leakage calculation. The increase in leakage causes a few challenges for day-to-day leakage management. It is difficult on operational planning since real leakage level is masked by this changing behavior of night use and the changes of network pressure pattern. In other words, we are a bit blind on our performance on leakage reduction. As mentioned earlier, hard works continue to keep the momentum of leakage reduction, but the graph tells otherwise. It is also difficult to make follow-up plans to bring leakage below the target line. We want to be more proactive in active leakage control using machine learning on leakage pattern, but this month forces us to be functioning reactively. This increase in leakage also cause further complication on understanding the water balance closure, which coupled with increased consumption. To get a grip of where we are at leakage, we work with our long-time partners at Artesia to understand the changes to the night usage pattern during COVID. Just as a fact, Affinity Water is one of the water companies that has extensive fast log DMAs. We currently have about close to 400 DMA out of our 1,200 DMAs, which are fast log. And this 10-second flow data allow us to understand the COVID impact to night use. I'm going to pass over to Dean to explain what we have been doing.
Okay, thank you very much, Eldos. If you can move on to the next slide. Great, thank you. Well, so I'm going to start by looking at putting this slide up and looking at how the network flow patterns have changed since the introduction of COVID-19. This is showing us 8 years of data from some of those fast log DMAs that Eldos was just talking about. There's about 200 DMAs aggregated into this graph. And this is showing us the flow on every day and every 15 minutes of the day for the last 8 years. We've got days along the bottom, time of day up the vertical axis, and the colors on the graph show the flow. The brighter the color, the higher the flow. So what we can see immediately for the first 7 days is there's a very regular pattern. We can see people getting up early in the mornings during the weekdays, later in the mornings at weekends. We can see when school holidays disrupt that pattern of flow. We can see the Easter break, the summer break, the half-term breaks. You can see the Christmas and New Year break, where everybody just stays in bed longer and gets up later and uses water further through the day. Towards the top of the graph, you can see the impact of the summers over the years. We tend to see during the summers an increase in demand, particularly during the evening, but also through the day. And that becomes apparent on this graph. And I've highlighted the summer of 18, which was that long, hot heat wave we had a couple of years ago. And that shows us that flow were elevated during that period, right the way through the day. And we get back to a normal pattern of use in 2019, and then the 23rd of March happens, and we all get asked to stay at home. Businesses are closing down, people are furloughed, schools close down. We've got people asked to work from home, and immediately we see a big disruption to the flows. We can see that on day one, people are getting up later. We can see higher levels of use throughout the whole day. We can see peak levels of use in the evening, which were higher than we saw in 2018. And that disrupted pattern continues right the way through the summer. Things start to get a little bit back to normal, but still, if you look in detail, patterns have still changed right up to the end of December of this year. If you move on, Eldos. This next slide, we can see that, that we get a similar pattern if we look around the country. So these are a number of other companies, fast log area monitors, and we've analysed them in the same way. Some have got longer data than others, but we can see back to 2018 And you can see the summer of 2018 on the left there as a bright area of increased use. Come over to 2020 and we can see consistently a disruption to the flow patterns. And it varies around the country, and we're starting to understand why that variation is there. If you look about halfway down the page, there's a particularly bright spectrogram where there was a really high increase of use during the summer. So if you're going to understand that a little bit more, we need to get under the hood and see what's going on, and start looking at what's causing that change in water use. So next slide, please. So if you remember back in lockdown, when we started, it coincided with a really hot, dry period. So one of the questions we tried to answer as well, is it just simply the weather that's causing this increase in demand? So we, in the collaborative study, were able to get 5 different individual household monitor data plus smart meter data analysed. And this slide is just showing some of the results of that. So if we look at the top left-hand corner of the slide, we can see the results from daily household consumption of one of those monitors. This has got data going back several years before 2020. So we took that historic data, we used that data to build predictive models of consumption based on seasonal and weather impacts, and then predict that forward in 2020 using the observed weather patterns we saw for this area. And that's the sort of the blue area of the graph. And then above that, there's a brown line, which is the observed household consumption. And then what we can see is that household consumption is higher than what we predict. It's also variably higher during certain hot periods, but even on normal weather conditions during the summer, we see an increased household consumption. So that's due to something else, and that something else is to do with COVID and the impacts of the lockdown on how we use water in the home. If we drill down into that a bit more and look on the right-hand side graph, we can see how the patterns of water use have changed during weekdays along the top and weekends on the bottom. A blue bar is a change in the diurnal profile upwards, so increased consumption. An orange bar is a change downwards. And what we generally see, and we could observe, actually, it's quite interesting, pre-lockdown, so the 2 weeks leading up to lockdown, we could see people changing their behavior. We could see people staying at home and starting to migrate from the office to home. Lockdown hits, and we see a very large change in the diurnal profile, more water being used right the way throughout the day on weekends and weekdays. Some significant increases in the evening time, particularly during certain periods. But even as we get to the end, and this data, as I say, goes up to the end of August, we still see a big change and more water being used throughout the day, weekdays and weekends, and further into the evening than we'd seen before. So that's due to both a change in behavior of how people use water in the home. And if we drill down a bit more into this data, we can separate out the internal and external use. And what we can see is that internal use is fairly consistently high during the day. The external use tends to be higher during the hot weather periods. And nothing new there, but it's the combined effect of more people being in the home for more hours, having to entertain children for longer during the hot weather, getting up at different times of day, taking their showers at different times of day. People used to shower before they go to work. Now they can shower anytime during the day. So all this adds up to quite a big change on household consumption. If we move on, Elders. So the other area of consumption we want to look at is the commercial sector, which is also heavily impacted by COVID. And so we're quite lucky in that Severn Trent Water had the foresight several years ago to set up a non-household consumption monitor, collecting 15-minute data from about 3,500 properties in 2016, and they've been continuing monitoring that ever since. And they made all that data available to the collaborative project, and this is some of the results from analysing that. And because we've got a really good, stable pre-COVID period, we can again build consumption models for the commercial sector and take into account all the normal seasonal activities, school periods, etc. Project that forward to 2020, look at what we think non-household consumption would have been in 2020, and then look at the observed differences. And this is what we're seeing on the left-hand graph. And we can see that by and large, if we take the whole sample right in lockdown, there was about a 40% reduction in the amount of commercial use. And that's quite a large bit, considering that many businesses were still functioning, most utilities, the whole health sector functioning normal or increased from normal. But when you look at some of the specifics in that, and we can break these down by SIC code and look at sport and recreation, hotels and restaurants, etc. Some of those sectors were 80% reduced through that period. That's a significant reduction. The graphs on the right show some of the daily profiles and different lines for different periods of lockdown. And there's some significant changes there. But one of the big changes is that the ratio between day use and night use is quite different for some of those sectors. And because when we try and quantify night use from commercial sector for reporting, we tend to build models based on their average daily consumption and predict night use, then those models that are built pre-COVID have now been compromised. And so they need to be updated and changed so that we can more accurately predict night use from the commercial sector. So I'm now going to move back to leakage and the particular issue that Eldus identified. And having understood what's going on within the households and within the non-households, we can start to look at the bigger picture on the network. So next slide, Eldus. So we've been, as Eldus mentioned, we've been working with Affinity for a number of years, helping them get the most out of their fast log areas. Because of the quality of the data we get from those areas and the consistency over time, we've built seasonal models to make sure we pick up all of the seasonal variation in night use for every day of the year over the past 4 or 5 years. And that's been used for reporting leakage more accurately over that period. What we found in 2020, though, was that those patterns of use had changed significantly. So we looked at the leakage data with Eldus and his team, and we agreed that actually, when you look at the ALC activity, look at the burst data, then the apparent increase we saw at the beginning of 20 MLD during the summer was probably not leakage, probably more to do with changes in consumption during the night. So just before Christmas, we spent some time rebuilding those models using the COVID consumption patterns along with the previous historic consumption patterns. And what we came up with was a model which showed that on top of the normal night use that we'd have seen, which is basically that green part of the graph, we can see additional seasonal weather related night use and additional behavior, COVID behaving night use patterns on top of that, which are giving us an increased customer use during the night time. Still largely coincident with the weather patterns, but it's the combined impact of COVID plus the weather that's led to that increase. And when we apply those night use values onto the minimum night flows, then we can effectively the leakage is then fairly consistent over the summer with a few ups and downs, obviously, but it gives us a much better picture. And this allows Affinity to both more accurately report their leakage this year during that difficult period, but more importantly, because we're not out of this yet, and we don't really know when these impacts are going to end. It's quite likely that there'll be some residual impact from lockdown going through the summer, and this should allow Eldus and his team to be able to react more quickly to any changes going forward in time by using the information and the insight we've got from COVID. So if you go to the last slide, Eldus. So I think, one of the things is nobody could have predicted COVID and the impact it's had. And it's interesting to reflect on this collaborative project. When we started, the project team and the people who were providing data said, well, let's just provide data up to the end of September because schools will be back and everybody will be back to normal. And here we are still in the middle of lockdown. So it's had a big impact on the way the patterns of water use have changed in the network. It's led to difficulty in both reporting leakage, but also how you target and specifically locate leakage in certain areas. And we have a situation where we're uncertain what's going to happen going forward. It's pretty clear that more people are going to be working from home over the certainly short to medium and even the longer term. So it's going to be important that we take the lessons of this collaborative project and apply it. And if we're going to have better resilience going forward, we're going to need to be using our data more efficiently and reacting quicker to changes. And through the collaborative project, we've been able to look at a lot of sub-daily household, non-household data, which has helped us understand what's going on in the network. I think we can take that knowledge and transfer that knowledge to a better understanding of what's going on in the network flows. And so even if you haven't got smart meter data in all houses, I think you can interpret what's going on in the network so you can better react in the future to help improve both leakage, pressure and demand management going forward for however long we are going to be stuck in some form of lockdown or change of behaviours working from home into the future. So I think we'll finish there, Bob, and allow time for the questions for you. I see there's a few popping up on the screen.
Yeah, thanks very much, Eldos and Dean. So just dealing with some of the questions on the screen first. From Steve Toombs is asking if non-household consumption reduction by 40% is reflected in non-household night usage as well.
So yes, well, it's not the same, I think, Steve. So as I mentioned in the slide we saw earlier, we've been looking at and quantifying the ratio between day use and night use, and that's definitely changed during different periods of lockdown. It's different for some sectors, and so one of the outputs of this collaborative project, we're providing data on how that's changed. Now, different people assess their night use in commercial sectors in different ways, but fundamentally, I think that means that you've got to look in more detail at the data you've collected during 2020 to get a good understanding of that.
Okay, another question, Jeremy is asking whether you've seen any difference between household metered and unmetered consumption as a result of COVID.
Yes, we have. I mean, measured households tend to have a lower consumption to start with, and what we saw during 2018, in fact, when we had a really heat wave, was that measured households had a suppressed consumption during 2018 heat wave compared to unmeasured households. I think, and we're still doing the final bits of the analysis on this, I think that we're seeing less suppression. I think measured households have also increased their consumption during that period, and I think that's born out of necessity. I think more than anything, you've got more people there during the home. You can't keep your consumption down. So yes, it's increased, but we've also seen measured households having an increase in their external use as well. So people are part of this project. We did a short social science study with Manchester University, and we had a question panel sessions with people around the country. And it was very clear that people saw things like the garden as an important place for relaxing, to get away from the office where they're cooped up all the way through the day and the night. Get out in the garden, enjoy the garden, and along with the kids and the children and the pets, just it leads to a greater water use, either for recreation or growing vegetables and that sort of thing. So yeah, so the answer is the short answer, measured and unmeasured both went up. And I think we see a different behavior to what we saw during the 2018 heat wave.
So what do you see, Dean, from all of the analysis that you've done, and obviously having this relatively granular data to be able to break things down in the way that you can, and what you've concluded from that. The potential impacts of what you're finding could be long-lasting, couldn't they? Depending on how long the impact of COVID lasts. And there's a lot of views that it's not going to be over and done with once we've all been vaccinated. It's going to be ever changing and developing into new strains, and and so on. So I know it's hard for everybody to look into a crystal ball at the moment, but these changes can have massive impacts on our water resources management planning processes, and what we're trying to do to mitigate the impacts of global warming and so on. So what are your thoughts on that?
So yes, I mean, it does take a big crystal ball to look at that, but what we do see and what we can start to understand is why are all these different changes happening. So I've presented some of this today, and I could have presented for a couple of hours on this, but it's not only more people in the house for longer during the day. I think the other impact is, particularly you see this in London, an exodus of people out to London into the surrounding areas. So I pointed to some of those high areas that on that graph earlier of different increase in flow in different areas of the country. Some of those, the highest ones, are in fact companies bordering onto London. And I think we've seen people who would normally be commuting to London now staying at home all day. So there's those impacts. We've got people using water differently during the day because they're there, they've got to entertain children. So whatever comes out, whether it's still a residual cyclic impact of COVID, we don't know what that's going to be, or whether it's just people actually spending less time commuting into the office and more time working at home, and I think it is going to change some of those patterns of water use. And we've built this as an industry, a water network, which has served us extremely well at supplying peak demands in the morning, less during the day, and then again a peak in the evening, occasionally getting caught out by a few really hot summers. Now those patterns of flow are going to change. And so I think it's just being aware that that things are going to be a bit different. I went to a conference during the summer on data science, which has nothing to do with water. We saw data science experiences from all sorts of different industries: banking, insurance, health sector, manufacturing, etc. All of whom said, we have lots of models which we run to help us with our business processes. Along came COVID, and we just threw them all out and had to start again. So I think what we can do with this project is trying to promote the findings from this project so that people can take these findings and help them to adjust how they look at things going forward. And it could have impacts for longer term water resources, as I said, with people moving around different areas.
Yeah, I think Joe's asked pretty much that same, or you've covered the answer to Joe's question there in terms of parameters for housing developments changing in the future, storage requirements changing, and so on. But I think the point is, this isn't necessarily just a change in the patterns of consumption, shifting from place to place within a total daily demand that stays the same. This is actually demand going up as well, isn't it?
Yes, yeah, and that's very clear. It is, definitely an increase, and it's not just a shift. It isn't just that the households come down and the non-households come down and the households go up. It's actually a much bigger change than that.
Yeah,
and that difference might settle down as we go forward. But I think the important thing is to monitor and track and react. And if we can do that with greater insight now, then I think that will help people going forward. And I see Judith put something in the chat about carrying on this in the catch-up lounge. I'll disappear into there at 12 o'clock and happy to answer any further questions from this session.
Well, I think there are quite a lot of questions unanswered there, which again pays tribute to the great quality of the presentation that you both made. So just one final comment from me. I mean, there's a lot of major issues that people are talking about as with PR24. Actually, well, it's not around the corner anymore. It started, one of the things that people are not talking enough about is this issue. There's a lot of discussion about lead as being a big issue at PR24, and various others as well. But this could be, as we've said, a major kind of long-term issue for the industry that we need to understand, and make sure we don't make investments in the future that are not as effective as we think they might be.
Yeah, fully agree. It has some very big implications, I think, on how we operate going forward.
Yeah. Okay, great. Well, thanks very much to both of you, Dean and Eldus. That was a great presentation, stimulating a lot of interesting questions on an issue that affects most people in the industry one way or the other. If you could answer some of those extra questions there, that would be really good, or make yourselves available in the catch-up lounge after 12 o'clock. That would be excellent. So thanks once again. So we'll move on seamlessly then to the last presentation this morning, which is another double act from James Hargrave, who is Regional Operational Leakage Manager at Anglian, and Jamie Worthington, who is also from Anglian. He is Planned Works and Asset Health Manager, I guess. Doesn't say that, but I presume that's the case. So welcome, gentlemen, and over to you.
Thank you very much, Bob. Well, hopefully the technology will work as seamlessly as it has for everybody else today. So as you've said, we're going to be talking about the practical twin, and probably the best way to describe that is to give you a very quick overview of the journey we're going to hopefully take you on this morning, which I will wait for technology to catch up. We go on to the next slide, trying to avoid the as it says here, we're going to be talking to you today is about our vision of the model that sort of takes, we have two conflicting things in facing us in leakage and in any delivery in the water industry, and that is basically the societal demands on us. We're providing an essential service to people, and the money in the systems and the like that we've got available to meet those demands. So out of that, we're then going to explore what we call the practical twin. What does that look like? This idea of symbiosis between detection, repair, and maintenance. And then, we're going to give you an example of what that twin means, because so often we can have these nice, pretty diagrams, these nice, pretty words, but it's actually what we do, how we turn them into something that's really meaningful and something that is significantly changing. And with that, we'll finish off with an example of how these processes are programmed seamlessly. Fingers crossed, we will not talk too much about all of these things, just enough, and we will help Bob to keep to the really good timings we've had so far. So I'm going to start off without further ado with this, this diagram here. Now, as we've all been hearing this morning, a lot of this morning's been talking about all the climate change, the increased supply-demand challenges that we face. I'm looking outside my window right now. There's about 30 centimeters of snow on my garden. We've just had an extremely hot summer. 2018, we had the same sort of challenges. Our world is in crisis, and essentially to meet that incredible challenge that we have in the lead up to AMP7, the leakage team and the Plan Works and Asset Health team needed something that helped us to actually create a systemic change, not just words, not just an objective or a mission, but actually to structure ourselves slightly differently, work together in a different way, so that we actually didn't fall back into our comfort zone of what we've always done before. It'll be all right. We actually needed to almost make ourselves feel a little bit uncomfortable and to create around us that enabled it. So scratching around for various ideas, this is the model that we fell upon, which is known as the Circular Economy Butterfly from the Ellen MacArthur Foundation. What you've got here is our adaptation of that, and I'm going to apologize now. Down the left-hand side is a whole pile of management speak. Please ignore it in the principal side. I do apologize. It's a whole pile of words that essentially what they boil down to is this is a system of how we can work together within the two constraining aspects that we face. On the left-hand side, increasing societal demand. On the right-hand side, finite resources. There's only so much water. There's only so many chemicals. There's only so many droplets that we can put through a system. There's only so many pipes, so on and so forth. And also only so much money. So what we've developed here in front of you is essentially a system whereby instead of a linear race that goes from one side to the other, where we're always just striving to the finish line, what we actually do is we create a system where in ever decreasing circles, we work together and we hand a baton on it in a continual relay from one system to the next, ultimately always aiming as we go through the process to minimize the leakage. And I'm not just talking about leakage in water. I'm talking about the leakage in our process, leakage in time, leakage in money, leakage in people's well-being because of all the difficult environments that we put them in, the stresses, the strains, but equally leakage in customer satisfaction. All of these things play together. And what we've got to do and what we've designed here is a model that starts to work together where it's not about actually just handing it over or throwing the baton over the fence. It's making sure that each stage of them, each circle, ends up with a baton that is ready to plug into the next circle of refinement. So we're able to continually build on each other's good work that has always gone before. So when you start at the need identification through to your solution, through to your service provision, they're all working together, continually building on each other, using all the sustainable ideas that we've got that everybody lives by today: refurbishment, maintenance, prolonging life, identification of innovation, seamless experience. But, you know, as I said to you, that's a pretty picture, and those are just words, albeit convoluted on the left-hand side. But all of those principles all drive us to trying to create something that's meaningful and something that actually drives us to be structured and work together in a different way, as James is about to bring to life for you in a very real way.
Brilliant, thanks Jamie. So if we have a look at the model of our vision of what a practical twin is, there are a few things that we need to remain clearly focused on. The first being that the customer should be the start and the end of the journey, that the customer can be internal or external, and that effective planning and enablement sets the road to success in an efficient resolution. On the left-hand side, we start with early event notification. This could be an alarm or indeed a customer inquiry. In the world, we can define this as proactive or reactive. We then need to identify the problem so that the correct solution can be formed in advance. Given the world in which we operate, prioritization and expectation sets both urgency and level of service. In order to succeed in either, we need to assess resource capacity against demand. Communication, whilst cliche, is a critical step to ensuring the correct relevant information is available to those who need it early. And to plan and commit. The old adage that the best laid plans of mice and men suggests that no matter how well it's planned, something can always interrupt the outcome. Whilst agility is necessary in our work streams, it's important to plan and commit where possible without change. An efficient schedule is one that is pre-planned and executed as such. Innovation, technology and method development, on the other hand, does need to be agile and needs to be informed. Safety and efficiency are two of the big drivers for necessary innovation. And TOTEX, what is a long-term solution? Make the right decision now to avoid the wrong outcome later. Monitoring, we must make sure that we've resolved the issue and that the issue does not become recurring, and to be able to report, audit and confirm the benefits, and then update. As I said at the beginning, the journey starts with the customer and ends with the customer. We also need to ensure our systems are updated appropriately to ensure continuous improvement. So if we apply the practical twin model to one of our work streams, let's look at the life cycle of one of our advanced leakage sensor-driven leaks. Our early event notification in this case is driven by way of a sensor alarm. The alarm in itself only indicates a problem, and we then use systems and analysis to determine the leak location and make ready for investigation. Our solution can only be determined following an on-ground investigation to identify the failed asset and survey it for resolution. Leakage carries with it the obvious priority regarding water lost against impact. Setting the level of service early enables us to decide whether the repair or resolution should be part of an advanced sensor repair schedule, or indeed if it needs immediate repair in a more reactive response scenario. From a communication and information transfer perspective, we at Anglian use Oracle OFSC field tablets and Prime POI follow-up app. Any resulting move to work is then committed via the same scheduling system used for the repair planning. Innovation in this example is to, where possible, use a VAC-X solution, which is safer and, when planned effectively, more efficient. And TOTEX, at the on-ground investigation phase, we will have identified the resolution required, whether it's repair, replace or renew. We use our integrated leakage and pressure management system and SCADA telemetry to monitor that the solution delivered had the effect that we expected, and all costs associated with the job are accrued via a master work order in SAP through Oracle. From a customer communication perspective, we surface our updates to our In Your Area and self-serve customer portals. All reporting is automated through Power BI. So if we lay this journey out in front of us, the timeline looks something like this slide. Our call to action can be from a number of different sources, whether it be an alarm driven by technology, predictive modelling, a catastrophic failure or preemptive preventative maintenance. The initial assessment is our time critical phase of the journey, an opportunity to triage, prioritise, define and assign. Throughout the journey, building in the capability for easy and, where possible, automatic updates to our systems and customers is key to ensuring a smooth handover. For our leakage teams, we then plan and schedule the appropriate resource requirements based on skill set and geographic location, and this is where we set our internal level of service based on the priority, in this case leak severity. Our initial response is a critical phase to ensure we identify the correct location of the leak or the issue and what requirements are there to be resolved. This includes on-ground survey and investigation and any enablement steps needed to formulate a seamless transfer to the planning and repair phase. So the virtual baton is now handed over to Jamie and his team. So over to you, Jamie.
So one of the key things that we have with it, why it's called Plan Works and Asset Health as opposed to delivery, is because we pick up on all those assets walking hand in hand with James's team, so that when we pick up that baton, it isn't just a case of put the thing in the ground or fix it. It's actually about having a look at its long-term life cycle. How are we going to maintain it? How are we going to ensure that the asset health is improved by our intervention, or at least maintained and its life is made the most of it? So in terms of resolving it, we start to triage ourselves. Is it a repair? Is it a replace? Is it maintenance? Is it support? Do we need to escalate it? Has the problem become worse? And also, above all, CDM, safety. We're bringing in a number of innovations in this arena. So just like we're talking about technological and analytical innovations in leakage detection, we've got to drive the innovations in how we do things, how we safely execute what's been handed over to us. So, as James already mentioned, vacuum excavation, but marry that with long-handled tooling, keyhole excavation, and suddenly you start to get to a place where you don't have an operative in the hole while you're busy doing this. Safety becomes paramount. You then, through the safety, you drive a more efficient program. And one of the things that we're driving through this is also to create a production line. It sounds twee, but we want to make it, while it's an exciting job to do, we want to make the process of getting the job done as boring as possible, so that things come in, they get processed in a very efficient way, and they come out the other end. Critical to that, enabling, is making sure that we take the information that has been provided to us, as we said, ready, fit for purpose to proceed, and we can then pick up on our enabling works, permitting, scheduling, dispatching our resources, looking forward, working ahead, trying where we can to build on that program, working with our reactive colleagues. If we're in an area for 2 weeks, what other work have they got there? Can we help them with that? Can we bring that reactivity into a planned environment, making it safer, more efficient, more sustainable? We then confirm that we've actually done the work through Oracle, as we've been describing, on-site, tablets updated, photographs taken, geolocations applied. But also there's another element to this, and this is where the asset health comes in. As we're capturing that data, that helps us with pipe condition, helps us with system condition monitoring. We can begin to actually understand what is the state of the assets that we've just intervened with. That then can feed into our ongoing model updates, our ongoing updates of the likes of digital twins, or ultimately near real-time modeling when we can. Systems are updated, customers are updated as automated as possible, trying to take some of that, the unnecessary human aspect through it. Then we can actually focus on the customers who need to be contacted. So we're looking at different ways that we can contact them. There'll be sometimes when we're out in the field, we'll be bringing a huge machine down the road, big vacuum excavator, yet there's no water flowing down the road. Why are we there? It's helping customers to understand why that might be the case. YouTube videos done through social media and the like to explain why we're doing things, and there doesn't seem to be a problem, but actually this is a preemptive activity to help the customers and improve their understanding. Then finally, there's the loop backwards. Again, concentric circles. How do we make sure that we learn from each of those interventions that we undertake? Could we have done it better? Could our process be improved? And that goes all the way back to the very beginning, working with James and the leakage team in this example, all the way through to the delivery teams. How do we continually look to optimize, to improve how we perform, to innovate from end to end in the whole sausage machine as it goes its way through that circular economy? With every concentric circle, how does it improve with every single intervention with both the system and our customers? Because the constraints on us and the demands on us are only going to get tighter. And the only way that we can actually stand up to those is not by putting one technology or one innovation ahead of the other, but actually bringing the two things together so that seamlessly we move from one end problem or something's been identified through to actually the end of it where we're maintaining it, looking after it, and the system is running as usual. So that's a very brief run through of what we've been trying to create, and thank you very much for listening.
Well, thanks very much, James and Jamie, for your presentation, which is quite a different context to the sort of stuff we've heard so far this morning. So quite refreshing and quite innovative in itself. So, I mean, I think what you're basically saying here is that we need to look at different technologies in combination, and we need to see things in a holistic way to get the best benefits out of everything, particularly in leakage, where I guess in your case, it's getting very, very, you're one of the leaders in the industry, so leakage is getting much tougher in terms of making further progress. But what sort of benefits have you seen from this kind of holistic system that you've described?
So some of the biggest benefits that we've seen from this has been around carbon reduction. So what we've been able to do is in line with the company's aspirations in terms of the embodied carbon targets that we've got and the like, we've actually seen that we've been able to outperform the targets that we set ourselves, because what we've been doing is we've been looking at the end-to-end and how we influence the whole process, from how we promote a job, right the way through to its completion. And using things like vacuum excavation means that we've got smaller holes, less disruption to customers, reduction in TM, reduction in the permitting, and also reduction in our durations. We've improved the time, the ability to operate as well, using smaller vacuum excavators. And so as a result, we've reduced fatigue within our teams. So this process has meant that we've been able to batch up our working. We've been able to work more effectively for the customers, interrupting them less, but also there's been the reduction in leakage run times. There's the reduction in our ability to respond also to outbreaks. So because we've got this underlying proactive activity, we're able to respond to any outbreaks quite quickly. I don't know if James has anything to add to that from his front-end piece.
I think, sorry, James, carry on. It's all right, sorry.
No, it's okay, Bob, carry on.
I was going to say, I mean, I think, what you are doing here in a sort of holistic, sort of process-orientated way is a good, presents a parallel with what one of the challenges we're trying to do through innovation, whether it's in leakage or in other areas, which is to look at innovations that work together, in combination, rather than looking at individual pieces of kit or individual technologies, which are developed by different groups of people, possibly different manufacturers. So are there any parallels, from the experience you're having, albeit within one company? So it's, at least it's all together in one big company, but, spread geographically. Are there any lessons to learn from what you've done here to the general challenge of trying to get different technologies in combination and to get, a 2 + 2 = 5 sort of outcome?
Yeah, I think there are some definite lessons learned, Bob. I think you have to tear up the rule book. And I think Alan has asked a question around people and process change, actually, and we'll probably come to that in a minute. But it doesn't matter what technology it is, if it's a noise logging sensor or if it's a pressure sensor, if it's NB-IoT, narrowband, Sigfox, LoRaWAN, doesn't matter what the platform is. The technology is there to do a specific job. If you don't then look at the method and the process innovatively and talk about your people and how the people that are there to actually deliver the work on the ground can work more innovatively, then you're only looking at it half-cocked. So you can have all of the technology at the front end. I suppose it's like buying a brand new Tesla, has all of the gadgets, it does all of everything you need it to do, but if you haven't got a driver's license or you don't know how to operate the vehicle, the road isn't actually there to drive it on, doesn't work. The principle works, but actually in practicality, it doesn't work. So I think what you've really got to do is take the technology side of things and understand that is pure, it's a pure form of something doing something. Factor in people and process. If you don't look at that innovatively, or even be prepared to literally throw out the rule book and start from scratch, then you are just bolting stuff on to an existing and aging both network, workforce, and we've always done it like that. Why should we change mentality?
Yeah, that's a great answer. Yeah, you absolutely rings true in so many areas of an industry that's been around 150 plus years, and a lot of the technology is almost as old as that, actually, in some areas. A couple of questions have come up on the chat here. So yeah, Alan has talked about when you're implementing new processes and people issues, resistance, old ways, old dogs, new tricks, I suppose, is the old adage. I'm sure you've come across those sort of challenges, but any great ways of overcoming those?
Thank you, Alan. It's the age-old question, and it's the age-old challenge, and the answer is, yes, we have come across those, and we continue to work through them. What we found when one of the big steps that we took was within Planworks and Asset Health, we created an entirely integrated structure of partners and Anglian Water, where I've got the production team who deliver a lot of these things. They report into one of our partner managers. It's all best for task, and that was one of our big cultural shocks. The big thing that we learned was we did it in stages together with the team. So it was quite a bold thing. Often you go through like 7-step processes or all these other things, and you kind of do something and you go, ta-da, this is our... Where actually what we did was we endeavored, first of all, to get the teams to understand why, get them behind the outcomes we were trying to achieve, and get them to see what some of these things, get them excited about some of these things actually meant for them. And that was a learning that we got from our LIFE program, which is a health and safety cultural change program. And it was all around actually saying, what does this mean for me, and how does this relate to how I act, relate to how it impacts on the people around me? So if I'm down about this and I'm negative about this, this undermines what other people are trying to do, and therefore I undermine their ability to achieve. And then we as a team undermine. So there was a lot of legwork and a lot of difficulty working with teams. And you know what? We're still going through that. We still have pockets of this as we continue to add in new bits of change. But it is actually taking the time to try and understand why it is that they are feeling this way against that change. And what often comes up is it's the first reaction, which is fear. I'm uncertain. Is this going to affect my job? Is, you know, this new piece of kit, this thing coming in, oh, that means more productive. That means you want to get rid of me. Well, actually, no, I want to do more leakage work. And the only way I can do that is because I need that machine and you working in a different way. And it's actually meeting people where they are and their fear. And that takes time, effort, which we're not comfortable with. It's the soft and what people call the pink and cuddly stuff, which as engineers and doers and constructors and everything else and data science, that's not our comfy place. But it is the place we have to go if we're going to affect this deep change.
So going to Daniel's question there, which is around cultural change, I think from my experience, Jamie, what you've just described is, you know, fairly normal within a cultural change program, people's fear of the unknown and, you know, helping them to understand what the future holds and, you know, taking them through it. Would you say this is no different in terms of this particular challenge, or are there particular things that are different from any other cultural change?
There are some advantages here, and I'll hand it to you, and that is the way that society has changed, where it's become more aware of the climatic and the other challenges that we face, the climate crisis. And that's given us an anchor, I think, to affect to affect the change with maybe in a different way. And again, picking up James's point, tearing up the rule book a little bit about how we anchor our change, not around money efficiency, but actually look at the benefits of safety, the climate, etc. Sorry, James.
Yeah, no, that's absolutely right, Jamie. And when you take, if you take an example of some of the things we did with the cultural change piece, change curve is, you know, if you do a big change all at once, the change curve takes this normal kind of journey, denial, and all of the other things that go with that. But actually, we haven't approached it with this. We need to change everything we're doing now to this approach. What we've done is we've trickle feed technology into the business as usual process. And we've brought people along with us on the journey. We've engaged with them. We've shown them the technology. And more importantly, we've fed back the results in a fashion that they can clearly see when it's working. There's no argument then as to whether it works or it doesn't. So rather than have this big change curve, what we have is incremental change now, trying to get people on board the train that is, if we carry on doing things we've always done in the way that we've always done them, we're never going to get any better results. And to just continually change in small increments. And that's, I think, helped us a lot. And it's testament to the culture of Anglian Water, actually, and some of the things and the major programs that go around in the background that help us support some of these change pieces.
Yeah, absolutely. Completely agree with all of that. So just to finish, James, Dean's asked a question there. Do you think this will help you react more quickly to future disruptors?
Thanks, Dean. I think the simple answer and the short answer is yes, because what we've created is an agile process. There might be some fixed points within that, but the next phase of what we're doing is going to be completely rewriting how we repair proactive leakage, and not just the proactive leakage work basket, but other things that we do, capital maintenance programs, capital investment and mains laying, small parcel investment, all within a kind of agile work basket environment. So when you get a disruptor, whether that be something that's driven by outside influences like COVID, workforce that hits the workforce potentially, or whether that's outbreak due to weather, we can move the workforce a lot more agile than what we're used to in the model that we're using now.
Right. Okay. Well, I think that was a fascinating session, Jamie and James, and I didn't even trip up on both of you having almost the same name. So I'm pleased about that. So, thanks very much for that. Really enjoyed that, and quite a contrast from some of our earlier stuff as well. It's always good to have some seeing things from different angles, and the people angle is as critical as any in our sector. as everybody knows. So on behalf of everybody, thanks very much for that presentation.
Thank you very much.
Yeah, and a virtual round of applause from everybody as well. Yeah.
Thank you very much.
Cheers.
Thanks very much, indeed, guys. Okay, I think we're at the end of our morning session, and maybe I can just reflect on that just for a moment before we break for lunch and tell you perhaps a bit more about what's in store. I mean, I think in the first couple of presentations, particularly, we saw really hard evidence of new ideas and new technology really kind of coming to the fore. So it's great to see that those things are out there and they're being developed, and it's great to see that we've got supply chain and water company people sharing the stage and co-presenting these things. So that was another thing that struck me particularly strongly. And then, of course, the third presentation around the COVID impacts, yet another challenge that we're having to respond and react to into the future as well, that makes the need to innovate and the need to improve and the need to change even greater because of potentially long-term changes in demand patterns. And then, of course, the final presentation, which was around people and culture, and really just looking at an holistic, almost systems-based way of working to make sure that everybody understands the big picture, not just the small pictures to what they do and the impact of what they do on the rest of the supply chain or the business chain, not just supply chain, could be. I'm not sure what the linkage between that session on what a practical twin, as it was called, and the digital twins that we hear so much about might be. I guess digital are sort of a system within that wider system, but that's certainly something that occurred to me. So thanks for all your questions, by the way. Some great questions and debates have emerged this morning. I think there is opportunity for you to continue the discussions with the coffee room, and there's there are networking opportunities as well. And I think that's about it. There's the exhibition as well. So and obviously through the chat, I think all of the presenters this morning have been quite happy to follow up on questions that we haven't answered on the way through. So I'm sure that will continue as well. But please continue the discussions, get the most out of the session. I think everybody meets again at 1:45, and my colleague Peter Simpson will be chairing the afternoon session. So I hope you've really enjoyed it this morning. I certainly have. I think it's been fascinating, and you can just tell by the questions that have come through that hopefully most of you in the audience have enjoyed that, or all of you in the audience have found that useful, enjoyed that as well. So I'll sign off for now, and thanks very much for making my job very easy today, and I hope you enjoy this afternoon session. Bye for now.